And I'm just going to talk a little bit about the use of IoT and data in occupancy, comfort, safety and wellbeing. The backdrop to this is that there's been opportunity that's been talked about in this area as being really significant way of improving the way in which our buildings work, improving the way in which people live and work, particularly in the office environment. But of course, a lot of frustration about the fact that very few sort of case study outcomes have really been generated and delivered over the period of time. So I'm just going to talk to you about a small number that we've been working on that I think tell us something about the potential opportunity in this area. Let me just start with something around occupant health. So internal air quality obviously is a huge issue for many parts of the world. And the ability to ensure really good air quality within buildings is a very significant part of occupant health. So here's an example of a system that we've been working on and installed in a number of Hong Kong buildings, where we have designed Internet of Things sensors and platform for display of those data. What the systems do is they monitor temperature, they monitor humidity, they monitor air pathogen levels, and identify the correlations between indoor air quality and people's health. And the system allows the building managers to predict the environmental conditions and the concentrations of indoor pollution, in the coming hours. So it predicts a few hours ahead what the forecast levels are going to be. And of course, that then allows us to control the purification system to operate in advance, in order to affect and improve predicted air quality. And based on the data that have been gathered on the performance of the system, it looks like we can reduce what we would call high pollution risk hours. So those are the hours in which air quality within a building gets significantly worse. We can reduce those by 30%. So that's a really significant way in which IoT data and predictive monitoring and analytics can really work with a building system in order to develop a really tangible result for something quite significant in occupant health and air quality. Now, likewise, when we come to think about people's comfort, obviously temperature and energy are very significant parts of this. So again, this is a system that we've developed and deployed in Hong Kong, where we do a lot of this work that uses artificial intelligence, to use machine learning on buildings data in order to improve significantly the building performance. So in this case, we have a couple of neural networks deployed on buildings data. The first of them uses data on air temperature, occupant footfall, and so on, to predict the energy needs of a building, a day ahead, that will result in a high level of comfort for the users of that building. And the second neural network optimizes recommendations for chiller settings, the chiller plant settings, to minimize the power use efficiency of that building, but at the same time meeting comfort needs. And the result of that sort of the ability to use machine learning on buildings data to predict the needs of the building on the basis of the comfort and the energy needs of users is generating between 10 and 30% of energy savings. Now, that of course, that's very significant, both in terms of cash, but also, of course, in terms of carbon, which is our newest currency, as it were. And that's, again, really significant, beneficial result for people who use the building, but also building owners and building managers and the broader environment. We've also been using a mixture of digital technologies and data to try and understand and improve human well-being. So this is an example actually that we've been doing in Tokyo, where we've deployed a mixture of environmental sensors, human count sensors, an AI camera, and emotion analysis device in order to see if we can understand how human productivity and human well-being relates to external and internal factors. So the environmental sensors measure temperature, humidity, CO2 concentrations, noise levels, and we can record voice data in order to get a good understanding, actually, of people's emotions and people's sort of energy levels. And we can examine how different environmental conditions and sort of external events and internal events affect human well-being and how that can be improved. And what you can see on this slide is an example of where we looked at two completely different events to see how human well-being and human productivity in the office was being changed, or improved, or in some case worsened by the kind of setup of an event or the setup of a building, or the levels of sort of temperature and conditions within the building. So really some quite detailed analysis and understanding now of how we can use digital technology, data, and sensors in order to understand human well-being and try and improvement. Of course, all of these things will become even stronger in the future. So we don't have to look at just individual buildings, we can look at whole systems. So here's an example of where we're working with the transportation department in Hong Kong to use similar kinds of methodologies, data and technologies and prediction methods, both to reduce energy consumption across the whole of the energy network and to analyze air quality to protect passenger health. So that's something that's happening quite widely and quite systematically across a whole city in this case. And of course, down the line, importantly, will be our ability to understand and improve the emissions from buildings. So here's an example again of a whole building system that we've developed that brings together data, including sensor data, from all kinds of different aspects of a building's operation, whether it's the waste systems or the energy systems or the water systems, or even the linked transport systems associated with the building. At this stage, of course, the main thing is to sort of understand what the emissions record of a building is looking like. And in time, of course, we'll be able to design the interventions and improvements and the recommendations that allow building owners to improve significantly the carbon and emissions performance of their buildings. That, of course, is becoming ever more important issue around the world. And indeed, in many parts of the world, there are legal or regulatory rules really now around ensuring that buildings become increasingly reducing their carbon footprint and emissions. We can now join these together across whole cities or across whole campus areas. And again, this is a piece of work that we're doing with Hong Kong at the moment, where we're connecting the devices and data from government buildings with the GIS systems to allow visualization, mapping, benchmarking, and performance across a whole city. And of course, this is also the case for for people who own buildings portfolios or campuses. Just in summary, the benefits from data, from sensors, from digital technologies have been talked about for ages, and we've all been quite frustrated, I think, at the kind of limited way in which it's been really helping people in practice. But I hope that's been a useful walk through a number of areas where, in terms of air quality, in terms of occupant comfort, or in terms of productivity and well-being, we're now seeing some real case studies of really significant benefits coming as a result of the systems that we can now deploy in buildings. And pointing to the future, doing that on whole networks of transport, for example, using it to really tackle the emissions performance of our buildings and infrastructure, and being able to do that across whole cities. That is the next exciting frontier of what I think we can now do.